In 1.2, we're looking at random samples. So first off, a simple random sample is one where each member of the population has an equal chance of being selected. Each sample of the same size has an equal chance of being selected. So everything has an equal chance of being selected. We also are going to look at simulation. We'll do that more in 1.3, but they introduce it here in 1.2. A simulation is a numerical representation of a real-world phenomenon. So you might simulate something instead of actually creating the experiment. We have a couple other sampling techniques too. So we already talked about random sampling. Every member of the population has an equal chance of being included in the sample. For instance, you randomly select 10 students out of the population of all Allen East High School students. A stratified sampling happens when you first break the population into strata, or groups, in which all of the occupants share a characteristic. So, for instance, it might be gender, race, religion, income, area. We break them into groups first. Then you're going to take a random sample from each of the groups. So we might divide up the population of Allen East into groups of freshmen, sophomore, juniors, and seniors. Then we're going to randomly choose 10 students from each grade level. Systematic sampling is choosing every nth member of the population. So you choose every 10th person who walks into Allen East High School each morning. A cluster sample is one that happens when you first divide the population into similar clusters, then randomly select clusters and sample all of the members from the cluster. So, for instance, you divide the population of Allen East School District into Harrod, Lafayette, and Westminster. You choose Lafayette, and every person in Lafayette is included in the sample. The convenient sampling is when members of the sample are chosen by being available and willing to participate. So your sample to represent Allen East High School could be your lunch table or students in your study hall. So now we're going to categorize each of these type of samplings. So we're going to ask every 13th person who comes in the building what their favorite color is. So if I'm looking at every 13th person, we're doing a system, so that's our systematic. For B, we're going to divide a college dorm into floors. We're going to select floors 2, 5, and 14 to ask every resident about the cost of room and board. So if we're dividing it up and then looking at everyone on only those certain floors, that's cluster. For C, ask students walking on campus if they will fill out a survey about activities on campus. That's convenience, because you're asking those who are around you. And then our last one, we want to divide the campus into male and female students, take a sample of 100 from each group to find out their college majors. So for this one, what we did was we divided it, then took a sample from each group. That's stratified. A sampling frame is a list of individuals from which a sample is actually selected. Undercoverage results from omitting population members from the sample frame. So for instance, if you're surveying all the senior class, you may have students who aren't at school the day of the survey. So they are not represented in your results. Sampling error is the difference between measurements from a sample and corresponding measurements from the respective population. It's caused by the fact that the sample does not perfectly represent the population. Remember I said, depending on what your sample is, it might change for each sample. It does not always reflect the population if you don't have a good sample to represent that population. A non-sampling error is the result of poor sample design, sloppy data collection, faulty measuring instruments, bias in your questionnaire, etc.